All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to learn how to graph quadratic functions. Okay? In a previous lesson, we learned how to solve quadratic functions, and now we're going to extend that knowledge to graph those quadratic functions. So let's dig into this. Okay. Like any equation in algebra, quadratics have what's called a standard form, all right? And that form is ax squared plus bx plus c. Now, these letters give you some information that you need. If whatever number is sitting in front of the x squared, that's the a value, if that number is positive, then the horseshoe shape of the quadratic function graph will point up. If a is negative, then the horseshoe will point down. All right, so if this was 3x squared plus 2x plus 4, because the 3 would be positive, the graph would point up. If it was negative x squared plus bx plus 3x plus 4, then the graph would point down. If it's just x squared and there's no number in front, we assume that a value to be 1. That's really important. And that would mean that the graph would point up. It would be positive. The other important part is whatever number is sitting out here at the end. This is called the constant term. And in a quadratic standard form, this constant term is the y-intercept. So right away, I've got something for you to think about and do. What is the y-intercept of x squared plus 2x plus 4? And I want you to think about the y-intercept in terms of a coordinate pair. So the y-intercept represents the place on the coordinate plane where the graph crosses the y-axis. And the x value of that coordinate pair will always be 0. So we know that it's 0 comma something. So what you're looking for is this c value. Okay, so you're looking at this equation, x squared plus 2x plus 4, and you want to find out what the c value is. That c value is 4, so the y-intercept is 4. The graph crosses the y-axis at 0 comma 4. So go ahead and write that right there in that box. All right, so we also have another little prompt here. What direction does negative 2n squared minus 4n plus 7 point? And you get to pick the shape that goes with that. So pick that shape there. You're looking at the a position number. Okay, so this coefficient here is negative 2. That's a negative number. So that means that this whole graph will point down. So we would circle B. Okay. Now here we are going to gather everything that we know in order to sketch a graph of f of x equals, and then we have a quadratic equation here in factored form. Okay, so we're going to have to answer these questions. Where does this function cross the x-axis? That would be, another way of putting that would be, what are the solutions to this quadratic equation? So we have the factors already because this is in factored form. The factors are x plus 7 and x minus 2. So the way that you find out what the x value is you just set each of these factors equal to 0. Okay, so x plus 7 equals 0 and x minus 2 equals 0. And we're just going to solve for x for each of these little tiny equations. So first, on this first one, I would subtract 7 from both sides. And you need to be doing this on your paper as well. This is not a movie. This is a guide. You need to be doing this on your paper. So now that would give me x equals negative 7. Okay. Over here, I have x minus 2 equals 0, so I would add 2 to both sides. Okay, and now I have x equals 2. That means that the graph crosses the x-axis at, and now I'm asked for coordinates. Well, anywhere on the x-axis, the y-coordinate would be 0. So I know that the y value for both of these coordinate pairs is going to be 0. The x value is just whatever this is. So this x equals -7, that means this goes here, -7. And here the x value is 2, so this is 2 right here. So the graph crosses the x-axis at -7, 0, and 2, 0. Next question. Where does this function cross the y-axis? So we're trying to find the y-intercept. Hint, use FOIL to convert from factored to standard form. Remember, FOIL is an acronym, and it stands for first, outer, inner, last. Make sure you write this down so you don't forget. FOIL, first, outer, inner, last. What it means is we're going to multiply the first two terms of each of these factors together, x times x, right? So that would be x squared. So we got first done. Now we'll do outer. The outer two terms are x and -2. -2 times x is -2x. So we put here minus 2x. Okay, I got the outer done. Now the inner, I'm going to multiply these two terms here. 7 times x, well that's positive 7x. So we write plus 7x right here. Okay, got the inner done. Now the last terms. We go here and we look at 7 times -2. That's -14. So at the end here, I'll put minus 14. And now I need to combine like terms in the middle. So I'll have x squared. And then -2x plus 7x is 5x, so plus 5x minus 14. And now we see that this is in standard form, ax squared plus bx plus c. A would be 1, b would be 5, and c would be -14. So the standard form of this quadratic function is, and here I would write f of x equals, make sure you're writing all this down. And then we just write this right here, x squared plus 5x minus 14. So the graph crosses the y-axis at. So here I have to remember that my standard form equation, let me move up here real quick. My standard form equation, ax squared plus bx plus c, that last term is the y-intercept. So if we go back down, here we have x squared plus 5x minus 14. So this graph would cross the y-axis at 0, -14. Make sure you're filling this out, please. Let you take a moment to get caught up. Okay, finally, which direction will this function point when graphed? Well, remember how we know that. So if we go back up and look at our standard form equation, whatever number is sitting in front of the x squared term, that's what's going to determine it. If that number is positive, the horseshoe points up. If it's negative, the horseshoe points down. So the number sitting in front of the x squared term here is an invisible 1, positive invisible 1. So which direction will this function point? Well, it will point up. And here I'm going to draw a little upward facing horseshoe like that, just so I know. That's the shape the graph will take. Okay, now we've gathered all of our details. We have the x-intercepts at -7 and 2. We have the y-intercept at -14, and we know this function is going to graph in an upward sloping way. We still don't know what the vertex or axis of symmetry are, but the above information is sufficient to get us to a basic graph. Now here, if you are a pre-AP student, so give me a second, students that are not pre-AP, I'm just going to introduce this. If you're a pre-AP student, I'm going to have you find the vertex by hand. Okay, so this is going to be something you need to read and do on your own. Okay, I have a key available if you get really stuck, but basically you're going to fill out all these boxes and you follow these directions closely and you can do it, pre-AP students. So pre-AP students, if this is your class, we need to pause the video here and you'll need to take, I don't know, 10 minutes or so, 7 to 10 minutes, and fill this out. This bottom space here, there's going to be a lot of calculations. It'll fill up this whole space. Okay, so that's for pre-AP students only. Okay, now we're back on track with everybody. Now we are ready to graph our quadratic function. Now on this occasion, I will tell you the vertex, which in this case will be a minimum, is located at this coordinate here, -2.5, comma, -20.25. And the axis of symmetry is a dotted vertical line passing through the vertex. Remember, the axis of symmetry is the place at which, if I draw a dotted line, I will split the graph exactly into two pieces. They will reflect on one another like that, okay? So we're going to take our information that we have and plot the quadratic function on this huge graph right here. So I'm going to be referring back to this page to get information I need in order to graph the function. The first thing I'd like to plot are those zeros, okay? That we call the zeros the places where the graph crosses the x-axis. That's this line right here. And so we said that the graph crosses the x-axis at -7, 0, and 2, 0. So here over at -7, I'm going to put a big blue dot. Okay, that's my first zero, or my first x-intercept. And over here, I'll put one at +2. All right, I'll write these numbers in because I can tell from the camera that it's not showing up very well. So this here, this is 7, and this is 2. Okay, those are my x-intercepts. Now, what else do I know? I know what the y-intercept is, so remember that was -14. So I'm going to go look over here on the y-axis and go down to where I see it say 14, and I will put a big blue dot right there. And again, for the ease of reading here, I'll put -14 right there. Okay. So let me label these points, or I want to plot one more point, the vertex. That was located at -2.5, comma, -20.25. We'll have to estimate the y position. But -2.5 will be right here, in halfway between -2 and -3. It'll be right here. And what I'll go ahead and do is draw my axis of symmetry, because the axis of symmetry is a dotted vertical line that is going to pass straight through the vertex. All right. This will help me as I move down the page, because this is a very big graph. Okay, so here comes my axis of symmetry. I'm actually going to do this one in red so it stands out. This is just going to be, you could do a dotted line. I'm going to do a big dashed line, just passing vertically straight down the graph through x equals negative 2.5. Okay, just like that. Now I need to find the vertex, and that was at negative 2.5, so somewhere along this red line, or red dotted line, negative 2.5, comma, negative 20.25. Okay, so I'm somewhere on this red dotted line, but at y value, negative 20.25. That is, here is negative 20 right here. So this position would be just below the negative 20 line. I'll put it right there. Okay, so that is the vertex. And I'm going to label all these points. Vertex. This negative 14 right here, this is the y-intercept. I'll abbreviate that y-int. Okay, make sure you're doing this. Make sure you're writing this. This is important. Up here at negative 7, I should have written, negative 7. We'll call this one of our x-ints, x-int. And over here at 2, I'll call this my other x-int. All right? So there's one final point we need to plot, and this point is one that you have to do visually. So wherever my y-intercept is, I'm going to look at, what I'm going to attempt to do is look at this axis of symmetry and reflect that point right there over to the other side. So you're going to find equal distance between this red dotted line and this blue point. I'm going to move over here and plot that point. And if you look carefully at the boxes, you can plot it exactly where it needs to be. Okay, so in this case, I'm going to skip a whole section, and then it will be right here. Okay, you could measure it with a ruler if you weren't comfortable doing it this way, but you need to plot that point. That's what we call the reflection point. Okay, so there's no math to find that, you just do it visually. It's going to help you graph, because now you have to do the hardest task of all. You have to sketch in a line that very smoothly passes through all these points. This bottom part is the hardest. It's hard to make this hoop shape. This will take practice, so I strongly recommend using a pencil to sketch it in, like shade it in almost, before you commit to a pen. So watch how I do that here. I usually do this in pieces. So first I'll start by connecting this reflection point down to the vertex. And what I'm doing is I'm just sketching in, I'm almost shading in. And this is really for my artistic people, this is something you're going to almost feel as opposed to knowing precisely what to do. This is where art meets algebra, okay? So you can barely see this, but what I'm doing is I'm shading in the line. I'm using the flat part of the pencil lead and shading in the line. And now I'll do the same thing reversed. Okay, hard for a left-hander, but I'm going to shade in my line. Take your time with this so it looks nice. You want to perfectly reflect this shape. Okay, so it's a real tender process that you do carefully. Take your time. Shade it in very lightly with the flat edge of your pencil so you kind of have a region to plot the point. So I'm just shading very carefully right now. I feel like Bob Ross. We have a happy little quadratic function here. Okay, this is where this quadratic function wants to live. You almost allow your brain to just intuitively plot this curve. Okay, so if you do this slow, it'll look nice. If you do this super fast, it's going to look like garbage. Okay, so we've made that nice, even curve, right? I'm just defining the curve here at the bottom. You see it kind of shading in there on the video. Now I need to extend that up here. So now I'll go I'll connect these two dots. Again, very carefully shading this in. Flat side of the pencil works best. If you just try to jump at it with a pen, it's not going to work out very well for you. Okay, so I'm just shading in with the flat side of the pencil, and I'm slowly seeing my curve come into form here. Right, see that kind of coming into form there? Now I'll do the same thing over here. Just shade up, shade back and forth, very lightly, very gingerly. There's no rush, there's no fire. All right, so we're shading very nicely here. Okay, the exposure is too bright. Let me move this light source. You see that shading in right there? Starting to shade in. Okay, so I'll keep shading. Okay, let me move the lights a little bit so you can see the whole shaded region. See that? There's my entire shading region right now. Now I feel a little bit more comfortable about bringing in the pen to kind of, I'm going to leave the lights like that so you can see what I'm doing. Now I'm going to bring in the pen to kind of try to connect all this. Okay, so make sure you've taken the time to shade very, very carefully. Now, to bring in a pen is dangerous because you make a mistake, it's going to look bad. What you want to do is connect these dots and stay inside your shading region. It doesn't have to be perfect, but we want it to look very nice. So steady hand here, steady hand, very steady hand here. Try to do it in one fluid motion. Right? Now I'm going to go from this dot down to the vertex and make a little hoop. And what I like to do is go ahead and make that hoop down there. See, I've made a little hoop so I know where I'm headed. Very carefully, this is the hardest part. Okay, very carefully bring it in just like that. And now we'll curve back and we'll draw with our pen from this dotted line down like that. Okay. You want to keep a curve to it. I made mine a little bit too straight right there. And then we'll go from this dot down to this dot here. Just take your time, take your time. There is absolutely no rush on this because you want to make it look nice so you have pride in your work. Okay, that's good enough. So you can, if you're still working, go ahead and work. Let me bring the light back in to see what it looks like in full light. Okay, too much light. Okay, there. That looks good. So we're not done. Now we're going to move up top and we're going to extend our line past these x-intercept points and just keep drawing the line up, up, up like that and put a arrowhead at the top and then do the same thing over here. Up, 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 up. Like that, arrowhead at the top. Okay, so that's it. It's not perfect. This is human drawn graph, so it's good enough. Right? So the rest of these won't be so complex and they'll be smaller graphs so you can be more steady with your hand. Great job, you did it. Now let's graph a bunch of these. And if we move forward in our little packet, we have a homework assignment here. In your packet, you will be looking at a fully solved number 1. In fact, let me bring that in here. Here's what you will see in your packet. I want you to see what I'm seeing here. So you have an example solved for number 1, and I'm going to go through that example here right now, right? In other words, I'm going to solve this again, but you have it already. I want you to watch what I'm doing and glance down at the notes so you can see how I'm coming up with everything that's written here. Because for my students who are not in pre-AP classes, what you're going to do is you're going to do everything you see, all of this stuff, down to the place where it says vertex calculations for pre-AP. You won't do anything below this, but you will do everything from this box up, including plotting the points and drawing in the graph. Okay? So here is the blank version. So I'm going to go ahead and do this again. Okay, so here's how we go about this. Here's my solution. And I'll write solution here. So what we're going to do is factor this quadratic. So first I have to rewrite it down here in the solution area. F of x equals x squared minus 4x plus 3. So I know you're not writing, you're just paying close attention to what I'm doing because you already have this written here for you. And now I'm going to make this little table, or this little template. Something plus something equals something. And those same two numbers multiplied together will equal something else. Okay, so this is the little template, and this is what you're going to fill out when you factor these simple quadratics like this. So I need two terms that add to equal the middle term, the b value, okay, in the standard form equation. This b value here in the standard form equation is -4. So I need two terms that add to equal -4. And I need those same two terms to multiply to equal the c value, this 3 right here. So two numbers that add to be -4 and multiply together to be +3. Those would be -3 and -1. -3 plus -1 equals -4. -3 times -1 equals +3. So let me write this. So, okay, so what? So f of x equals, and now what I'm going to do is put an open parentheses and write x, and then I'll put -3. X minus 3, and then I'll close up that parentheses there. And right next to that closed parentheses, I'll put another open parentheses and write x. Then I'll take this second number here, -1, I'll put x minus 1, just like that, and then close up the parentheses there. Okay, so now we're back to our factored form. This is something we already worked with to solve on the first page. So if you need to refer back to that first page to see what to do, you're given the factors and you're going to set each factor equal to 0 and then solve for x. So that's what I'm going to do here. I'll rewrite each factor. X minus 3 equals 0. Okay, and x minus 1 equals 0. Just like that. So take a moment to write that. And now I'm going to solve each of these tiny equations for x. So first I'll add 3 on both sides. And I'll get x equals +3. Okay, and I will add 1 to both sides over here. And I'll get x equals positive 1. These are my two solutions. These are my two x-intercepts. Okay? Now we'll write out a little sentence here. So, our function crosses the x-axis at. Our function crosses the x-axis at, and now I'll put coordinate pairs here. At where? At 3, 0, and at 1, 0. Okay? Oops, can't see it. All right, so now what? Now I need to identify the y-intercept. The y-intercept is this last constant term sitting here. It's always going to be a number sitting out by itself. And I can write the y-intercept is located at, and now I need to put a coordinate pair, open parentheses. The x value will always be 0 at the y-intercept, so located at 0, whatever this number is, 0, 3. Okay. Finally, I need to identify the direction that this graph will point. So I'll say since A equals 1, and 1 is a positive number, the graph will point up. And I'll put that little upward pointing horseshoe. Okay? Now, for my pre-AP students, you will go ahead and calculate the vertex down here below. And you have an example shown on your homework, but you need to go ahead and perform those calculations, pre-AP students. For the rest of us, we're going to go ahead and graph, just so you know, in this equation, the vertex is at 2, -1. All right? So we're going to plot all of our points. We'll plot the vertex, the y-intercept, and the two x-intercepts, and then we'll graph it in. First, we'll plot the vertex, 2, -1. So that's 2 on the x, -1 on the y, right there. So I'll plot that in blue. Okay, this is the vertex. Now I'll plot my x-intercepts. This is where the function crosses the x-axis, and that would be 3, 0, and 1, 0. All right, so I'll go up here and plot at 1. This is 1, and this is 3. Finally, I'll plot the y-intercept. The y-intercept is always this last term, so that would be at 3. Up here on the y-axis, I'll go find 3 right here. Put a big dot. 3. Okay, that's the y-intercept. So this 1 here, this is an x-int. So this 3, this is an x-int. And this 3 over here, this is the y-int. Get all your points labeled so you know what they are. Now we need to find that reflection point. So what I'm looking at is I'm looking at the axis of symmetry. The axis of symmetry always passes right through the vertex, and it's a vertical line. So it's going to be right here. Plot this in if you would. Now what I'm looking for is I want to reflect this distance over here and plot that point. It looks like it's going to be right where my pen is. Yep, so right here. It's real easy to do visually. You're just plotting that reflection point. All right, so you can already see the shape of the graph. It's upward sloping, and I'm going to shade it in and then plot that in. This is a small graph, so I'm going to go a little bit faster here. Okay, but still take your time. Make sure you're passing through all your points, and you're making that nice, clean, even hoop at the bottom, so it's not pointy. You want it to be rounded. Okay, like that. You see it? Now we'll take the pen and we'll complete the process. So first I'll do this hoop down here. All right, nice hoop. And then we'll go from this point to this point. Do the same thing on the other side. And then finally I'll extend the quadratic graph up to show that it continues forever. Just like that. So now I've graphed the quadratic function. Looks cool. We graphed the y-intercept, the x-intercepts, the vertex, and the axis of symmetry. Okay, so here's the work shown. And I will stop the video there so you have enough time to complete some of these other problems, because you have 2, 3, 4, and 5. The one thing I will leave you with are the vertices here for all of these examples. Let's see if I've got those ready. Might have to give them in class. You know what I'm going to do? I'm going to give them in this video, but it will be up to you to watch this video to get this information. Okay, so we already had the vertex for number 1, and number 1 is fully solved for you. The vertex for number 2 is going to be, so I'm just going to write down here, the vertex is at 1, -4. Now, just because I'm giving this out doesn't mean that my pre-AP students don't have to show all of the work, okay? So that's number 2 vertex. And then we'll move on to number 3, if I can get to that second page. There's just 4 problems total. So your homework is 3 problems. The vertex for the third problem is -2, -4. So here the vertex is at -2, -4. And finally, this vertex for number 4 is at -2, -1. Okay. And of course, if you don't have this information, you can always solve for the vertex, but that is for the pre-AP students. So that will do it for this video. And just to cover what we did a lot in this video. We learned how to graph a quadratic equation. And now I've misplaced all of my notes. Let's see here. Here we go. So we learned how to graph a quadratic equation. Right here. We graphed a big one. My pre-AP students will learn how to find the vertex by hand. And at the beginning of this assignment, we learned about standard form, ax squared plus bx plus c, something I would memorize. We learned that this leading coefficient tells us the direction the graph will point. This final constant term c, whatever's here, that's the y-intercept. We learned how to convert from factored form to standard form. And we learned how to find the direction of the graph and the y-intercept. Okay? Very good. Good job today. Now, hopefully, you will know something about how to graph quadratic functions. All right, so good luck with the homework. Listen, I'm going to share the video link to this video with you, and if this was a lot to come down on you, please watch the video again so you understand what to do, and read the notes, talk to your friends. If this video is helpful, please give it a thumbs up. That really helps promote my channel, and it helps tell me that I did a good job here with this video. And if you have not already, please subscribe to the channel and hit that notification bell so you are always alerted to new videos on this channel. Thanks.